Section 1C, decimal place values. So now that we've dealt with whole numbers, let's look at decimal place values and decimal numbers. The set of real numbers, remember we've talked about natural numbers, those are your counting numbers, 1, 2, 3, 4, 5, 6, 7, etc. We talked about whole numbers, 0, 1, 2, 3, 4, 5, 6, 7. Real numbers deals with all the numbers that have decimals to them. 76.1243, whatever. If you see a decimal point and continues on, that's a real number. We've gone beyond whole numbers and natural numbers to the set of real numbers. So real numbers is the set of all decimal numbers, which can be some very interesting numbers along the way. So what changes there? Well, now we've got this decimal point. I'm just going to start with a 0 here, a 0 point. So when you've got this decimal point, that's breaking up the whole number part of it. The left-hand side of that decimal point includes the whole numbers. The right-hand side includes the, I hate to use the word fractional or partial numbers. Right? Anytime you see something to the right of the decimal, that means it's part of 1 as opposed to being a multiple of 1 or many ones. 619 is 619 ones, right? If you take 619 times, you have 619 of something. But when you get to the right side of the decimal point, now you're looking at a part of it. So if we're talking about cupcakes, then we have 619 cupcakes. But if we have 0.619, that means we have part of a single cupcake. So we have part of a cupcake. So that's what this decimal point is doing. It's breaking up the whole part from the partial part. So for right now, we're going to ignore the whole part, and we're just going to look at the decimal part of it. And let's just put some numbers here for the sake of being. So 1, 2, 3, 4, 5, 6, 7. Now when we're dealing with decimals, the numbering system is kind of similar to when we're dealing with whole numbers, but reversed. And we do a slight modification to how we say it. We do not put commas on the decimal side. If we remember, this spot here was the ones. That was the ones place. Well, when we come over to the decimal side here, that first one is the tenths. Tenths place. So it's like tens, but you put a TH in there. So tenths place. Be happy you're watching this as a video, because in class that gets quite dangerous when I start having to put these in place here. So we have the tenths place, and it counts the same way. Then we have the hundredths. Hundredths place. Again, 100 TH S. Hundredths place. The thousandths place. The 10,000ths. Place. The 100,000ths. The millionths. And the 10 millionths. Right, and it carries on the same way. If you remember coming this way, we had the ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, right? Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. Just that TH. The spelling stays the same, except when you get done writing it, you put the TH in there. Notice that there is no oneths place. Oneths. Doesn't exist. Okay? We can't have a oneths place. We have ones place over here, and then it starts tenths, hundredths, thousands. So be careful of that, because that's one of the big mistakes that people make when they're trying to look at numbers, is they want to count it the same way as they did on the whole side. And they start trying to do periods there, and they go, oh, okay, so this must be they look at that as the tenths and the hundredths, because they're like, well, if I go over 3 this way, ones, tenths, hundredths. So they go over this way, ones, tenths, hundredths. But that's wrong. There is no oneths place. So it's the tenths, hundredths. But then you do get into these periods again, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions. So it does follow the same process. Remember, no commas, and there is no oneths place. Now realize when you're working with decimal numbers, there is absolutely nothing wrong with counting your way out, going tenths, hundredths, thousands, 10,000s, when trying to find the place values. In fact, let's put a number up here and determine the place value of a certain number, or a certain digit, or the opposite, determine what digit is in a place value. So let's say I have 0.562193. And I want to know what number is in the thousandths place. The thousandths. Let me write that down. I want to know which number is in the thousandths place. There is no shame, and I do it too, in going, okay, the first one is the tenths, so I have tenths, hundredths, thousandths. So the number 2 is in the thousandths place. Perfectly allowable to do that. Don't feel you have to just automatically know which one's in which place. What if I make it the 100 thousandths place? Tenths, hundredths, thousandths, 10,000ths, 100,000ths. So the 9 is in the 100,000ths place. So just count your way out. Don't be afraid to do that. I've been doing this for decades. And yeah, when I look at it, I can quickly grab the first few because I've been doing it for so long. So I just look at it and I know that's the hundredths place and that's the thousandths place. But when I get further, I start counting them out too. And I start it here so I don't make a mistake. I start tenths, hundredths, thousands, 10,000s, and work my way out. Now, what if I want to know what place the 1 is in? What place is the 1 in? That's right here. So I go, oh, the tenths, hundredths, thousands, 10,000ths. So that's in the 10,000ths. The 10,000ths place. What place is the 5 in? Oh, the 5 is in the tenths place, right? So we can pull those place values out. Once we know those place values and we recognize them, now we can take a number in standard form and write it in words, or we can take a number in words and write it in standard form. There is one little modification which we should know, and that is, how do we state a number in words when it's written like this? Well, what we do is we look at the number as if it were a whole number. So look at what's on the right side of the decimal point. And envision it as being a whole number. Doing the periods, 1, 2, 3, 1, 2, 3. The commas and this blue line underneath are just to help us to be able to read it. Those are not part of the actual number. But now I can look at this and go, ah, that's 5 million. Oops. That's Mr. Davis writing the wrong a comma in the wrong spot. Let's try this again. That's 562,000. And see how easy it is to make a little mistake? That's okay. Mistakes are okay. We just have to look and go, oops, and go back and fix it. So 562,000, comma, 193. So we have 562,193, and then to complete it, we look at the rightmost place value. So we look at that right there. So basically we ignored the decimal point and anything to the left of it, and read this as a whole number, and then we look at the rightmost place value, and we're going to add that on. So that's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, and so we put millions. 562,193, 562,193, tenths, hundredths, thousands, 10,000s, 100,000s, millions. Millions. So we just use that rightmost place value. That was a pretty big number to do that. Let's go to something a little bit smaller. .36. So putting it into words, ignoring the decimal point and the whole side, that's just 36. The 6 is in the tenths, hundredths place, hundredths. And that's all there is to it. So if you can read whole numbers, and you know the place values for the decimal part, then you can put a decimal number into words. 36 hundredths. Let's take it just a step further and say, well, what if we put a whole number part with it? 12.053. We read the whole part, 12. Remember I said that and was saved for something special, and we'll see it with decimals? When we see a decimal point, we can read that as and. So 12 and then we get over here and look at this, we have 53. Tenths, hundredths, thousandths, rightmost place value, thousandths. $12 and 53 thousandths. Okay, so let's go the other direction with that. What if I give you a decimal number in words? Can we put it into standard form? $61,018. 61,018. 10,000. No, let's go for millions. Okay, so 61,018 millions. So think about it. Remember when we were putting them into words, we ignored the decimal point and the whole side, and we said, okay, let's write that out as that number, and then look for the rightmost decimal place value and put that on the end. So with this, we don't have a whole part, so we can put it as 0 point. We've got 61,000. Well, how do you write 61,000? 1, right? 61,000, 18, 61,018, 0, 1, 8. 61,000, remember if you had a comma in here, 61,018. So I'm going to get rid of that comma because we don't put that in there. And then millionths. So we need this 8 to be in the millionths place. So if that's the tenths, hundredths, thousandths, 10,000ths, 100,000ths, it's not in the millionths place. I need one more place to put it in the millionths place. So I'm going to put in a 0 in here. So now I have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Now another way you could do that, I kind of threw that in there and then had to fill in this place. You can do something like this. 61,018 millionths. Well, we know we need the millionths place. So you can go 0 point, well that's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So now you've given yourself the places and you know that the last number has to be here. You know 61,018, 61,018, and you can just write those in here. 8, 1, 0, 1, 6, and you go, oh, I need another 0 to put it in the right spot. So that's a second method. You can, what do you say? Well, this tells me what the rightmost place value is going to be. So I give myself all those places. This tells me the whole number equivalent, 61,018, so I can write that out, and then I just go, okay, 8, 1, 0, 1, 6. I still have space to fill in, make it a 0. So that allows us to go from words to standard form. Which leaves us with just one more thing to look at here, which is necessary versus unnecessary zeros. A 0 is really nothing, right? So depending where it is in a number, it can be necessary or unnecessary. 60412. I have a 0 here. I want to know whether that 0 is necessary or unnecessary. Well, if it's unnecessary, I can remove it and the number will stay the same. So if we look at that, that's 60,412. If I remove that 0, it turns into 6412, which is 6,412. Did the value change? Did the number change when I did that? Yes, it did. So that 0 is necessary. We can't do that. You can't get rid of that 0 because it actually changes the value of the number. What if I have 5,400? I want to know if these zeros are necessary. Well, what happens if I get rid of them? Then I end up with 54. Well, if your pay is $5,400 a month, are you okay if I give you only $54 a month? Of course not. So those zeros are definitely necessary. In fact, we call those placeholders. Zero, 41. If I get rid of the 0, then I have 41. Did my amount change? No. 41 is still 41. That 0 is unnecessary. You can get rid of it. What about 5.630? Yeah, 5.630, which we know is 5 and 630 thousandths. What happens if I get rid of that 0? I get 5.63. 5 and 63 hundredths. Now on the decimal side, it may be a little hard to recognize that, but those are the same thing. Here I have 0 thousandths. I have 6 tenths, 3 hundredths, and 0 thousandths. Here I have 6 tenths, 3 hundredths, and I don't have any thousandths. So those numbers are the same, so that is unnecessary. Basically, when looking at necessary zeros, any numbers to the left of the decimal point, or I should say any zeros to the left of the decimal point that are beyond all other numbers, are unnecessary. Any zeros to the right of the decimal point that are beyond all other numbers are unnecessary. So if I had something like 00562.41900, I started the decimal point, I worked my way out past all these numbers that aren't zeros, and then I'm left with just zeros dangling off here. Those are unnecessary. I start at the decimal point, I work my way to the right, and I get past numbers that aren't zeros, and then I get to where there's just zeros dangling off there. They're unnecessary. But if there are other numbers that follow them when moving from the decimal point, they become necessary. So if I have 502.0031, starting at the decimal point, working my way to the left, I have a 2 and then I have a 0, but after that 0, there's another number that's not 0. That 0 is necessary. If I'm going to the right, I have 0 followed by a 0 followed by a 3. So I've got these zeros, but if I go further to the right, I come to another number that's not a 0. So those zeros are necessary. So that covers section 1C, decimal place value.